Hi, hello everybody. I am Manisha Chima Ojla from Chandigarh Business School of Administration, Chandigarh Group of Colleges, Landra, Mohali, Punjab. Today we are going to talk on a topic that is related to majority of our work here. Suppose I am from the business side and I want to bring certain product for the people, for the customer there. What I need to understand is that what is their level of income, how much they are earning, how much product, to what level will they be able to afford the product. Now what I shall do, I will be asking each one of them, what is your income? If I go on asking each one of them, the population is going to be in the lakhs and crore, which is not feasible to ask each and everybody there. What I will do, I will try to understand some value from which I can think about the whole, for which I can understand the whole of the population there. What I do is, I find out the central value around which the salary is falling. Second thing I do is that what is the minimum value there and what is the minimum income there and what is the maximum income on the other end. These are the different ways from which I can analyze how much people are earning, what is their range of income, because I want to understand that the product I am bringing in the market, what should be the cost, to what extent that can the people buy that product. Now, to understand that, I need to find out one value that can represent the whole population, that can represent the income of everybody there. I need to understand, I need to scan that whole thing. One is, I understand the central income, that is the center point of their income, around which all the income are separate. Second way is that I find out how far the income is separate, right from the minimum income and moving to the maximum income there. This task is not that easy as it sounds. There are different ways to find the central value. There are different ways to find how those values are spread out there. I am going to talk on this topic, how we put these two things. We put one as central tendency and this other thing we put as central dispersion. Today we are going to start with central tendency. What is central tendency? What all are included in it? Suppose, let's say one product is costing 12 rupees, 14, 16, 18 and 20 there. Somebody says central value is this 60 because I add up all these and divided by number of items, I say it is this. Suppose there is one more value out there, 22. Again I try to find. The other person says center number can be found if you arrange the numbers in the ascending order. The one which is coming in the middle, that is the which can be called as the central value. What does it mean? It means there are different ways to find the central tendency. Let's talk on this. One is I arrange the numbers in some order, ascending order, then find out the central value. The other is I add up all these and divide it by some. I call it as central value, or I can call it as mean also. Now, we are going to start with the mean there. What can be the different types of mean? There can be three types of means out there that can be calculated. First type of mean is called as arithmetic mean. Second is called as geometric mean. Third is called as harmonic mean. We will be talking about the arithmetic mean. Arithmetic, we are going to pick this topic here. Now, what it is, the first one, he says it is something that the single value is there that is going to represent the whole of the data. There is going to be one single center income of the whole population around which we can say that income of everybody is separate out there. If you talk about the class, the marks which are being scored out there, maybe somebody is scoring 30 out of 30, the other person is scoring 10 out of 30, the third person is scoring 15 out of 30, then even we say that which is that number around which all numbers are spread out. That center value, we say it represents all the numbers around that. Sometimes it is referred to as middle number also. Measures of the central tendency yield information about particular place or location in a group of numbers. Suppose I say like this, my house is on the right, I have 2 kilometers, I have market. On the left, I have maybe gym out there. Right, if I move to this side, maybe at 2 kilometers, I have a college. Maybe if I move back on the back side of my house, maybe on the 2 kilometers, I have a park out there. I said this is the center, is where are my houses. What does it mean? It tells me how far the things are on all the sides. Then what is the mean, what is the center value which I am going to consider that these things are near to which center place where my house is located. That is what it says. Measure of central tendency gives information about a particular place or location in a group of numbers. These are the various types of central tendencies. If I talk about the first two, I don't need to make any order in ascending or descending. The last one, 3, I need to arrange the numbers in the ascending or descending. Then I find out the center number. The moment I say that I have to change that position of the element because I am arranging it in the ascending or descending order, that means position is relevant out there. Position is important there. That is why we put the last 3 ones in the positional center value. Maybe any of the method can be used out here. Now, I am going to combine this with the type, what are the properties of the arithmetic mean there. First we talk about the data representation. This is the same of product 1, 2, 3, 4 or first day, second day, third day and so on. What is the way to find out how to arrange these numbers? These are just 10 or 12 out there, very easy to find out, add up and do the calculation, divide and understand it. But it is not going to be in the real situation, it is not going to be that easy. If I will be asking the people about their income, the population from a city, I am going to ask each one of them. I can't write it in this one because those are going to be probably, it is going to be lakhs and crores, those people who are working and earning out there. So what is the second thing I do is, I take the certain numbers and I represent how many times that number is represented. We all have done the tables, we know it that if I multiply 1200 with 3 is same as adding 1200 here 3 times. Same as that 1400, I take it's occurring only once out there. What I do is, I make the task representation of the task comparatively easy. I write sale and I write how many times that particular figure is occurring there. Now this is the first one when I am not classifying. It is ungrouped, it is generic, it is a raw data, nothing processing has been done on it. We call it as individual series. Second part is the discrete. Discrete is when we do a little bit of work on it, we make a grouping of it and we put it in a right order. We say that sale, then we write the frequencies for our understanding and we call it as discrete. Third is the sale in rupees. I have categorized it. What I do is, now see, in case I talk to the people in a city about their income, how is it going to be? Somebody will say that I earn 1.25 lakh, somebody might say 1.27, 1.28, 1.29, 1.30. So what it is, I'm going to have a lot of data in a various form out there. I need to understand, I need to arrange the data in a way that I can understand. I make a grouping of income. I say those people who are earning 1.25 lakh, from 1.25 lakh to 2 lakh, I'm going to put them in one category. Just for understanding. Somebody might say that it is not going to be accurate. May not be, but at least I understand. I need to find out the way to represent the data there. So this is the same way what we have done. This raw data we have categorized. What we say is starting from 1100 to 1300. We count the figures which are falling in this first category and I put it 3. 1300 to 1500. only one is occurring out there. So we make the data in this form, and this form is called as continuous series. We get 1 point there. Ungrouped data, individual. Group data, discrete, and continuous there. I hope you get it. Individual, we are not considering. If 1200 is occurring twice, we are adding it twice. Second case, if 1200 is occurring thrice, we multiply it by 3. We make a table there. Third one, continuous, we make the categories there and we write the frequencies after that. Now, how the arithmetic mean is calculated? It is, we add all the numbers, we divide it by the number of items there, and we represent it by x bar. Okay. Why do we need to calculate the average? Moving to the formula before that, we need to find it because we want to talk about the whole population, what they are earning, how middle number, we want to find it out around which all the incomes are falling. So in case the students are scoring marks, what I say is which is that center mark around which the marks of all the students are lying. I can't say the student who has scored 30 out of 30, all marks are lying around it. No, there must be some figure out there that some of the people are scoring more than that and some are scoring less than that. How many they are scoring less or more, we find out that center number to understand the whole marks of the whole class. That is what is written, that you find out one value for the whole mass of data. It enables me to do the comparison. Suppose I say that there are 2 classes out there, 2 sections there. First section has the average marks 20, around which the marks of the whole class are lying. The second class has the marks average maybe 25. So what do I conclude? That maybe first class is comparatively weaker or say requires more of assistance to improve. I'm going to put some efforts there because they are getting average 20, the second class is getting 25. So I get a comparative which is a better one there or a one which requires more of assistance there. It enables me to do the comparison. To establish relationship, we understand what all the factors are there that can make our work better, that can make us, what all subjects are there where we can need to work on. So we understand about that. To derive inferences about the universe to which the sample belongs to. Suppose the marks is 20 average and somebody gives me 5 sheets out there. Those marks are around 20, 22, 19 and so. It's more that I will say that it belongs to that class where the average was 20. I find out the average of those samples. I compare it to the average of the whole class. Where it is lying closer, I said probably it belongs to that section only. So that is what it says, to derive inferences about universe to which the sample belongs. To aid decision making, if the government wants to make any decision that is related to the income of the people, what they will say, which decision should they go for, which is going to affect the majority of people. Suppose the average income, they bring a scheme which is for the people who are average earning is more than 5, so that they can decide. They need to make a decision. They will be making this decision on the average of the income there. So what it says, decision making, it assists us. If there are 2 classes, one has a little less average, I will make a decision that I should give them more. I should take some extra work to them so that they can work better. So I take a decision based on that mean or the average marks. Now we come to the point, what are the properties of arithmetic mean? First one is, some of the deviations of the item from the arithmetic mean is always 0. Let's do that part up there. First is, same is 12, 14, 16, 18, 12, 20, 18, 24, 16, 12 and so on. Now, this data is ungrouped. Why do we call it ungrouped? Because we are not considering that how many times 12 is occurring. It may be occurring 10 times, we are going to add it 10 times out there. It is a raw data. It is an individual type of data there. What it says, we take the total of it. After that, we divide it with the term of the number of items there. How do we calculate x bar? That is equal to the sum of the numbers, sum of items, divided by number of items. If I take sum of these, 12 plus 14 plus 16 plus 18 plus 12 plus 20 plus 18, 24 plus 16 plus 12, I get this equal to 162. How many total number of items are there? Those are 10. I put it equal to 16.2. What is 16.2? It is the mean. Mean is represented by x bar. What the first property says, if you subtract each of the number from x bar and you add up those numbers, you get equal to 0. What does it mean? 12 minus 16.2, this gives me minus 4.2. 14 minus 16.2, this gives me minus 2.2. 16 minus 16.2, it gives me minus 0.2. 18 minus 16.2, it gives me 1.8. 12 minus 16.2, it gives me minus 4.2. 20 minus 16.2, it gives me 3.8. I find out all the differences there. 12 minus 16.2, it gives me minus 4.2. What I do after that, I take sum of these numbers. When I take sum of these numbers, this sum comes out to be 0. So what it says is that sum of the deviation of the items from arithmetic mean is x bar, item is x, then the sum always comes out to be 0. Let's take one small example. 2, 4, 6, 8, 10. What is x bar? X bar is equal to sum of 2 plus 4 plus 6 plus 8 plus 10, the total out there, divided by the number of items, 1, 2, 3, 4, 5. So what is your x bar? That comes out to be equal to 6. Now I subtract 6 from all numbers. 2 minus 6, 4. 4 minus 6, minus 2. 6 minus 6, 0. 8 minus 6, 2. 10 minus 6, 4. Let's add it up. Minus 4, 4 gets cancelled. Minus 2, 2 gets cancelled. What am I left with? 0. Sum of the deviations of all numbers from the mean is equal to 0. That is the first property of arithmetic mean. It says the sum of the deviations of item from the arithmetic mean is always equal to 0. Okay, we come to the second property. What the second property says, sum of means we are taking the summation of deviations of the items from mean. Sum of deviations of the items from mean. This is x. This is x bar. These are the words being put up there. This is the one. Sum means summation. Square deviations means deviations. If I take this part, deviation of item from the arithmetic mean, that means x minus x bar. When I say square, I put it square out there. From the mean is always minimum or least. Means if I will calculate x bar from the x bar, I am going to calculate the deviation, square of the deviation. It is always going to be minimum. What does it mean? In case for any data, I take an assumed mean. Assumed mean means in numbers we say किसी को भी assumed mean ले लेते हैं हम. That is what numbers we take, and then we make a square of it. We say then it is not going to be the minimum. Let's check it out. We take these numbers, we calculate the mean, we put it 16.2, we take the deviation from the mean, 12 minus 16.2, 14 minus 16.2, 16 minus 16.2, 18 minus 16.2. Then he says, not only deviation, you have to take the square of it. I take square of the deviation, which comes out to be minus 4.2, it gives me 17.64. 0.2.2, it gives me 4.84. 0.2, it gives me 0.04. I take square of all the deviations from the mean and I sum it up. And I sum it up, this is not the sum, I sum it up, it comes out to be 139.6. This is the sum when I take deviations from the mean. Now second step, I assume that the mean is, let's take this case, I assume that the mean is 16. 12 minus 16 minus 4. I take the mean is 20. So 12 minus 20 minus 8. 16 minus 20 minus 6. 16 minus 20 minus 4. 20 minus 12 minus 20 minus 8. And we take the mean, we take the deviation from the assumed mean, which we have taken as 20, and we take the square of these figures, and when we square it, minus 8, it gives me 64, minus 6, it gives me 36, minus 4 square 16, minus 2 square 4, minus 8 square 64, and I take the sum of it, it comes out to be 284, which is more than when we have taken from the mean. What it means is that in case we go for any value other than when we took mean, deviation from the square of the deviation from the mean, it comes out to be 139.6. When we assume the mean to be 20, it came out to be 286. Let's take the third one. We said assumed mean is 16. This is the assumed mean, which is 16. 12 minus 16 minus 4. 14 minus 16 minus 2. 16 minus 16, it gives me 0. I write all deviation, that is x minus 16. I take square of these deviations. Minus 4 into minus 4 gives me 16. Minus 2 into minus 2 gives me 4. 0. 2 square 4. Minus 4 square 16. I have taken square of the deviations from the assumed mean. That I have taken 16. So I do the total of it. I get 140. Though this is 139.6, the other one is 140. Maybe very close, but not more. It is more than when we took from the mean. Next one, we take the assumed mean against. This next one is taken 18. When we took from 18, 12 minus 18 minus 6, 14 minus 18 minus 4, 16 18 minus 18 gives me 0. I am taking these values of x and I am subtracting it from 18. What is it? It is assumed mean. So I am subtracting. After that, I take the square of the item. Minus 6 into minus 6 gives me 36. Minus 4 into minus 4 gives me 16. Minus 2 into minus 2 gives me 4. 0 into 0, it gives me 0 there. Now what it says, that you take any numbers here, you are going to get the total here 172, which is again more than that mean taken from the mean, that is 19.6. He says maybe you have taken a number out of these. Let's take another number. Let's take it 15. Assumed mean is 15. X minus 12 minus 15, it gives me minus 3. 14 minus 15 gives me minus 1. 16 minus 15, it gives me 1. 12 minus 15, it gives me 3. 20 minus 16, it gives me 15, it gives me 5. 18 minus 15, it gives me 3. 24 minus 15, it gives me 9, and so on. Now I take square of these numbers. Minus 3 square, it gives me 9. Minus 1 square of it gives me 1. 1 square of it gives me 1. 3 square of it gives me 9. Minus 3 square of it gives me 9, and so on. I write the squares of all the numbers. Then I take the sum of these squares. It is found to be 154, which is again more than 139. Now I can say that whenever I calculate the square of deviations used from the mean, it came out to be minimum. When I considered the mean, then I got 139.6. Else every situation I have got mean more than that. That is why I can say sum of the squares of deviations from the arithmetic mean is always minimum or least. Both the words have the same meaning. This is the second property of arithmetic mean. Let's move to the third property. This is the third property here. What does this property say? Suppose we have two set of numbers. Suppose we have two set of numbers, 2, 4, 6. Other side we have, let's take 4, 6, 8. These are two set of numbers. We don't know what are the sets of numbers, but what we are told is that first set where we don't know the elements, they say in the first set there are 3 elements and the mean is 4 of the first set. They say from the second set, they don't give us the elements. They say second set again has 3 and the mean is 6. Now we are put to a task. What is the combined mean of these numbers? How to find those combined when we know that we know the mean of two things, two set of items, we know how many items are there. Is there any way that we can find the combined mean of these all items? I don't know the items. I just know this, that first one has mean, 3 items are there and 4 is the mean. Second item is there and 6 is the mean. Now they are asking me, they want to know what is the combined mean. If we take these two, we don't know what are the items there. Is there any way we can find it? Yes, we can find that way. M1 says set of the items in the first one, which is the 3 that is given to us. X1 bar is the mean of the same set of items that is given to us 4. N2 is second set of item which is given to us 3. X2 is this mean of X bar 2 is the mean of second set of item that is given to us 6 divided by Number of items in the first plus number of items in the second one. Let's try to apply this in our practical work there. Serial number. Marks, first set. These are the marks which are given to us. These are the second one. Our relevancy lies here. This is the only part that is given to us. What I do is, I make two groups of students. To the first group, I gave them these numbers. I told them to find out the mean of both the numbers. Now I give this task to the second group of students. I tell them, find out, in case we combine, we have two sets of data, where the first one is sum is this, second sum is this, mean is this out there, and the number of items are 5 in each. Find out the combined mean. What it says, now we write here, number of items in each is 5. Mean of the first one they have written, mean of the second one is written here. Now it says, we are going to make the product of these two. 14.4 into 5, 72, plus the second one, 18 into 5, 90. Now he adds up two products, that is n1 x bar 1. He adds up these two numbers. He adds up 72 plus 90 divided by n1. That item is 5, both the cases. He does, second group does the calculation. They say the combined mean is 16.2. If you have two set of data, you don't know what are the elements, but you are given the number of items in each set here and mean of each set, you can find out the mean in case we combine all the data out there. What shall be the combined mean in that situation? We come to the fourth postulate, fourth property. What does fourth property says? He says, if each of the value in a variable x is increased, decreased by a constant c, the arithmetic mean will increase or decrease by the same constant c. What does it mean? I take three numbers, 2, 4, 6. What is the mean here? I add up these numbers, divide by 3. I get mean is equal to 4. I add up 2 in each number. If I add 2 in each number, 4, 6, 8. I take the sum of these, 18 divided by 3. The new mean is equal to 6. We increase the numbers by 2. Our mean also increased by 2. Let's take it out. If we minus 2 from here, 2 minus 2, 0. 4 minus 2, 2. 6 minus 2, 4. 6 divided by 2. Now we want to find the mean. Mean comes out to be equal to 2. What was the mean earlier? 4. Why did I get a 2 out there? Because I decreased each item by 2 and my mean also got decreased by 2. What if I multiply by 2? Let's take the original items, 2, 4, 6. I multiply all items with 2. Here the mean was 4, original. Multiply by 2. 2 2s are 4. 8 2 4 2s are 8. 6 2s are 12. Mean comes out to be 8. Earlier it was 4. Now it is 8. Why did it change? Because I multiplied each term by 2. And my mean also got multiplied by 2 from 4 to 8. Let's take the division. If I take division here, 2 by 2, I get 1. 4 by 2, I get 2. 6 by 2, I get 3. My mean comes out to be 1 plus 2 plus 3, 6 divided by 3, I get 2. Mean was earlier 4, now it is 2. Mean got divided by 2 because I divided all elements by 2. What does it, if I try to summarize, if you multiply the numbers with a constant, why is it saying? That it is not that you multiply the first term with 2 and the second one with 3. No, this is not going to work. You have to multiply all terms with the same number. 2, 4, 10, 16, 5, 20, any number. But it should be same for all. He says if you add a constant to all numbers, or if you decrease and subtract the constant from all numbers, you multiply with the constant, you divide with the constant, your mean is going to change in the same by the same constant. See, here we took x as all numbers. Mean came out to be 16.2. He added 2 is added to all numbers. The mean also got increased by 2 numbers, 16.2 to 18.2. They added 3 to all numbers. When they added, the mean came out to be 19.2. How do you calculate mean? Adding all numbers divided by the number of observations. 16 from 16.2, it came out to be 19.2. That means all got increased by 3. Mean got increased by 3 because we increased all elements by 3. They subtracted 5 from all. Mean got subtracted by 5. 16.2 minus 5, 11.2. Subtracted 3 from all elements. Mean also decreased. The same way. Multiply all elements by 2. Mean also got increased by 2. Earlier it was 16.2. Now it is 32.4. Next, multiplied by 4. This mean also got multiplied by 4. Divided by 2. All numbers. Mean also divided by 2. Divided by 5. All numbers. Then mean also got divided by 5. Naturally, if we summarize it, if you increase, decrease, multiply or divide a numbers, all observations by a constant, your arithmetic mean also gets increased, decreased, multiplied or divided by the same constant. Now, we come to the fifth property. What does fifth property says? The product of arithmetic mean and the number of items on which the mean is calculated is based is equal to the sum of all given items. Basically, it is the definition of the formula for which how you calculate the mean. How do you calculate mean? You write mean is equal to sum of the observations divided by number of observations. What I do is I take number of observations to the other side. How will I write? X bar into number of observations is equal to sum of observations. That is what he has written. Product means multiply. Arithmetic mean x bar. That is what you have done. X bar multiplied. Number of items. This is what you have written. Number of observations. This is equal to the sum means sum this, sum of all the given numbers means observation. It is just the rearrangement of that formula there. Now let's take this out here. These are the numbers which give us 162 and 16.2 is the mean. He says number of items are 10 and mean is this. He multiplied the two things, multiplied and you get 162. What is 162? That is the sum of the items here. If you don't get anything, then you can message. Okay, we come to the last one. If each item of the original series is replaced by actual mean, then the sum of these substitutions will be equal to sum of the individual items. What it says, if I take 2, 4, 6, I take smaller number because it's easy to handle, then we will move to the bigger ones. 2, 4, 6. What is the mean? Mean comes out to be 4. What is the sum? It is 12. He says you replace all numbers by mean. If I replace 2 by 4, 4 again same here, 6 I replace by 4, it comes out to be 12. What happened? If we replace the number by the mean and we take the sum of it, this sum is going to be same as the sum of the individual items. Sum of the individual items, that is what he has written. In each item of the original series, these are the original series, is replaced by the actual mean. This is what we have done. We replaced 2, which was the actual observation, by 4. We replaced 6 also by 4. 4 also, we can say 4 by 4. Why? Because sometimes you might get a mean that is not figuring out here. Originally there is no value of that. So in that case, we say all values are being replaced and you take sum of these. He says replaced by mean. Then sum of these substitutions. These are the substitutions whose sum comes out to be 12. He says will be equal to sum of the individual items which are given here. So what we say, this is the sixth property. We have taken these numbers, we added these numbers, we got 162. We calculated its mean by dividing it with 10 because there are total number of observations are 10. Now whatever mean we have got, we replace 12 by 16 by 2, 14, 16 by 2, 16, 16 by 2, 18, 16 by 2, 12, 16 by 2, 20, 16 by 2, all numbers replaced by 16 by 2. Then I take the sum of these numbers, it comes out to be same as this. This is the substitution by mean. This is the original numbers or original observations. The sum of the two is equal. That is what the last one. If you replace the item by the original series, of the original series, but if you replace it by the actual mean, then the sum of these comes out to be equal to the sum of the individual items. Now, we come back to that slide there from where we had started. We talk about the properties. This is just that we are we go for compilation of whatever we have studied right now. We started with what the arithmetic mean is, why do we need to calculate, what are the various ways in which the center value can be known, why do we need to know it, because we can't talk about each one, how they are, what they are earning, or what is the purchase capacity of a person there. We can't talk individually because grouping we have to do. For grouping we need to understand what is the center value there, because we are going to make the product, bring the product according to that. So what it says, the first property, arithmetic mean can be calculated. It says the first one, sum of the deviations of the item from the arithmetic mean is 0. Second is sum of the square. Deviations from the mean is always minimum. Third one, if you write the formula there, that can be, if you have two set of numbers, you know the mean, you know how many elements were there, and you combine that set, then even you can find the arithmetic mean, that is called as a combined mean of two or more elements there. If each of the value, if you multiply that each of the observation, increase it, decrease it, multiply it, or you divide it, all observations by a constant, your mean is going to change in the same proportion. Then the fifth one, the product of arithmetic mean, that is x bar, multiplied by number of items, that is n. This is equal to sum of the items there. This is just the rearrangement of formula, that's what we said. Last one, if each of the item original series, it is replaced by the actual mean, then sum of the actual mean, sum of those all substitutions there, that sum is going to be equal to the individual sum of the individual items. Anything still? These we need to understand the properties of arithmetic. These are the 6 properties there. We conclude the topic here. Hope you understand. We will continue with the same one. Have a nice day. Thank you.